So let's answer some questions on this. This is a worksheet. What do you think? Start number 1. Since nobody's going to talk to me, I'll start. All right, so number 1, it says, what is the sum of the interior angles of an octagonal box? What in the world does that mean, an octagonal box? 8-sided figure, that's right. So if I have 8 sides, and it says, this is number 1, and if it says find the sum of the interior angles, a lot of people miss this on the quiz. I don't get it. Because there's just one formula, plug it in, and you're done. What do, Lonnie? Very good. It's 8 minus 2 times 180. 8 minus 2 is 6 times 180. And what was that? 1080? Is that the answer? Okay. So it's 1080. That's all you do. Okay? You just go 6 times 180, put it in a calculator, and use a calculator, okay? Usually I kind of tell you to kind of stay away from calculators because I want you to do things in your head. But I want you to get right answers too, okay? I want you to get right answers. So just put it in a calculator and get an answer. And that's it right there. But you got to know what to do. It's not 8 times 180. It's 6 because it's 8 minus 2. N minus 2 times 180. All right. I'm just going to go through these problems and find things that I kind of remember that would be on the test. Look at number 3. Let's skip down to number 3. Let's change colors instead of just going boring white all the time. All right, it says if the measure of each interior angle of a regular polygon is 171, find the number of sides of the polygon. Didn't we have a problem like this on a quiz? Yeah, we had something very similar to it. So what did we do? Just to get an idea of what it looked like. I drew one of these dealies, right? And yeah, and it said if the measure of each interior angle of a regular polygon is 171, so that's 171 right here. Find how many sides this polygon has. All right, so what did we do? We extended this, didn't we? And we found the exterior angle because it's a little easier dealing with that, I think. So we found the exterior angle. And how do you find the exterior angle? 180 minus 171, which is what? 9. So this is not really drawn to scale, but that's 9 degrees. Really tiny little angle right there, 9 degrees. Now, how do I find out how many sides this has by knowing the exterior angle? Tell me, Javi, what is it? Very good. 360 divided by 9. Okay, and what is that? 9 goes into 36, what? 4 times and a 0, so what? 40 sides. So this thing has 40 sides. Good thing I didn't draw it out, right? Because I'd have to have 40 sides going around this thing, and that'd be a lot. That's all there is to it. So if they give you the interior angle of a regular polygon, you can find the exterior angle, 9 degrees. That means every single exterior angle is going to be 9 degrees. How many exterior angles am I going to have? Well, remember, they always add up to 360, right? All the exterior, the outside angles, they all add up to 360. So how many do I have? 360 divided by 9, and that tells me how many exterior angles I have. Well, that's the same number of sides that I have, so that must mean there's 40 sides. Okay. We've talked about that quite a bit in the past, haven't we? Let's see what else I want to do. Yeah, let's do number 4. Might as well do this one. This is a parallelogram, right? So let's, what did I do for that? Oh, I sheared. Let's just make it look like that. Alright, pretty close. It's tilted a little bit, but I don't really care about the tilts. Let's do this. It throws a couple diagonals in here, and let's put some numbers in here. They say this is angle 1 right there, and this is angle 2 right there. And it does say it's a parallelogram, and it says that angle 1 is x plus 12, and it says angle 2 is 6x minus 18. Now, you might just be able to guess what to do here, okay? And it's probably a decent guess, but you're not going to do this every single time. A lot of people are getting into that I don't know what I was trying to say. There's a word, I can't think of the word. But anyway, a lot of you guys get into the, what was it? Habit. Okay, that's good enough. It wasn't exactly the word, but it's pretty close to what I was saying. You kind of get in the habit of just setting stuff equal to each other, no matter what. Well, a lot of times that'll work for you. Okay, I'll be honest with you. A lot of times if you just set stuff equal to each other and you solve for x, that may be enough to get the answer that you're looking for. All right, but you got to make sure that they really are equal. So let's do that. Remember, this is a parallelogram that they tell you. So look at angle 1 and angle 2. If it's a parallelogram, you know that this side is parallel to this side. And look at this. This right here is a transversal. So tell me something about angle 1 and angle 2. They are equal to each other. We've talked about this pretty recently, haven't we? They're equal to each other because they are what to each other? Alternate interior angles. Good. So alternate interior angles are equal when they're part of parallel lines. So it's just a matter of setting these two equal to each other. And some of you guys may not, have thought all that out. You just saw this and you're like, okay, I don't know what to do. I'll just set them equal to each other. And that will get you by for a few problems. But not every single problem. It's not always going to be equal to each other. In this case, they are, though. Right? So you just set them equal to each other. Just do the math really quick. Subtract the x from both sides, you get 5x. Add an 18 to both sides, and you get 30. And then you divide by 5, and you get 6. Is that the answer, though? No, you don't just circle that, because the question, I didn't write the question down, but I will. It says find angle 1. So if it says find angle 1, you don't just circle 6, do you? You got to plug it back in, don't you? So you plug it back in for this one right here. You could actually plug it in for this because 1 and 2 are the same, but this is easier. Plug it into this, and so it's 6 plus 12, and angle 1 is what? 18. So that's 18 degrees, and angle 2 is also 18 degrees. Okay? How many times have we done a problem like this? Many, 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 many times. All year long, right? Even when we didn't talk about parallelograms, we did stuff like this. We set things equal to each other. We solved for x. We plugged it back in. We've been doing that all year long. And we're going to continue to do stuff like that. So you should be used to that at this point. All right. Let's do another one. Let's drop down to... Let's flip it over. Let's do number 15. I know I skipped a lot ahead, but I'm trying to think of ones that you might see something like this on the test. And that goes out a little bit further. Kind of looks like that. And then they draw this thing right here down like this, a right angle. And they say this is 59 degrees right here. And let's label it NOP. This is Q and M. Alright, we got it all labeled. It says, oh, you know what? Why did I draw it dumb like that? Let's draw it like this. It says it's an isosceles, doesn't it? So I just copied that side, flipped it around, so that's what it should look like. So we'll try to make it look like it's supposed to. There we go. That's better. Alright, it does say it's an isosceles trapezoid, and you got to read it. You got to make sure that you do read it, because I just looked at the picture. It looked like it went out a little bit further, but it really doesn't, because it says it's an isosceles trapezoid. Find angle MNQ. Well, you got to find where that angle is. A lot of you guys have trouble finding the angle that they're asking for. It says find angle MNQ. Make sure I wrote it right. Yep. So where is that? There's M, there's N, there's Q. So I'm looking for that angle right there. You think, what in the world? How am I going to do that? I don't know any of these angles in here. But you do know something, though, don't you? Well, first of all, you know two things. You know this is a right angle. So if that's a right angle, and this is the angle you're trying to find, what I would probably think, I'd probably think about this triangle right here, wouldn't you? So you know that this would be a right angle, wouldn't it? What else do you think you know? Remember, it's an isosceles trapezoid, so this side and this side are equal to each other. What do we know about the angles of an isosceles trapezoid? The base angles. What is it, Nicole? Well, no. Okay, all four angles add up to 360, but tell me something specifically about the base angles of an isosceles trapezoid. See? We need to go over this because nobody's giving me the right answer. the base angles are equal to each other. So look, if this is 59 degrees right here, what else is 59 degrees? Tell me, give me a letter. It's M, right? So this has got to be 59 degrees. Everybody see that? All right, so these two have to be equal. That's only true when you have an isosceles trapezoid. If it was just a regular old trapezoid, you wouldn't have enough information. You wouldn't know. All right? Everybody with me? All right. Is that enough information to find angle N? Yeah, absolutely, because look at this triangle now. Look at MNQ, this triangle. I've got a 90, I got a 59. All I got to do is find this one. So what's my math? One simple math problem. What do these two angles do? They add up to be what? Now, just these two angles, this one and this one. Two angles. They don't add up to 360. They don't add up to 180. Say it. They add up to 90, right? Because look, I heard 180. That's what I heard, okay? You don't have to get rude with me, all right? He might have said it, but I just didn't hear it. If I would have heard it, I would have acknowledged it, okay? So these two add up to 90 degrees. So we go 90 minus 59. And what's that, 31? And so that's this angle right there. Okay, so that angle right there is 31 degrees. So you had to know a few things to be able to figure that out. And that's how you do it. It's recorded, so I'm not going to talk anymore about that. Let's do number 17. Let's drop down to 17. It says the length of the median. Now again, they say median. I don't recall them using the word median on this trapezoid. Alright, we looked it up, and I didn't see median of a trapezoid anywhere, but I did see the word midsegment. Okay, and we have talked about that, and I think that's what they're referring to when they refer to the median of the trapezoid. They should have said midsegment. Alright, so let's see it. It says the length, well, instead of median, we'll say midsegment of the trapezoid EFGH is 13 feet. Now, and it doesn't give you a picture, does it? So let's just draw a trapezoid. Does it have to be isosceles? No, it doesn't say it's isosceles, so I'll just draw just an everyday, normal looking trapezoid. We'll extend that to about right there. But it does say the mid-segment, doesn't it? Well, kind of. It says median, but we've talked about that. So where is the mid-segment? It goes from the midpoint here to the midpoint here. Alright, and what do they tell you the mid-segment is on number 17? It's 13 feet, so that is 13. It says if the bases have lengths 2x plus 4, so we'll call this one, it doesn't really matter which one you call what, but we'll call this one 2x plus 4, and the other one is 10x minus 50. Now this one's a little bit harder than what you've done in your homework problems, because usually they just gave you numbers here. They gave you, this was 20, and then they asked to find what this one was right here. So they made this a little bit tougher for you. So let's see what we would do. Well, do you remember the little formula? How do you find the mid-segment? You take the average of these two, wouldn't you? All right, so let's do that. Let's write down a little formula here. How would you find the average of these two? You add them up, right? So we add them up, the top and the bottom, the two bases, and what do we do to them to find the average? Divide it by 2. And what should that equal? If we take the average of these two, what should that equal? 13. Everybody see that? So that's how you should have set it up. Now, we didn't do one exactly like this when we did our homework problems, but you still should have been able to do this because it's still the same exact process. You just have to do a little bit of algebra here. So let's multiply both sides by 2. All right, let's see what we get. Let's add some like terms up here as well. 2x plus 10x is 12x. And then 4 minus 50 is negative, what's that, 46? And that equals 13 times 2, which is 26. So that wasn't so bad, was it? We just added like terms. Everybody see what we did here? Just added like terms to get this. I multiplied both sides by 2, right? And that's why it canceled out here, and I multiplied this side by 2. And now we just continue. Add a 46 to both sides, and so 12x equals, that's a 2, and that's a 7, and what's that? 6, right? X equals 6. Is that what they're asking for, though? Yep, it says find x. That's what it says. It says find x. So we're done. right there. Now, if they wanted to, 17. If you wanted to, what did we say it was? I forgot it already. 6. Okay. It's terrible. My memory's horrible. So x was 6. What if they asked you to find the two bases? Then what would you do? Plug it back in. Exactly. Let's do it in our head. 2 times 6 is 12 plus 4 is 16, right? Now watch this. Now without even putting this in here, what do you think this is? Remember, 13 is halfway between these two, isn't it? It's the average. So look, if I went from 13... Wait a minute. Did we do this right? Yeah. It looks shorter, but it may not... Yeah, let's just plug it in. Because I think I drew it wrong. I probably should have put this one down here and put this one up here. Because this is probably the shorter one, I'm thinking. Let's plug it in. What do we get? 10 times 6 is what? 60 minus 50 is 10. So even though it looks like the longer one, it's really the shorter one, isn't it? But I still got the same numbers, though. I got 16 and 10. Is 13 halfway in between 16 and 10? Absolutely. So everything works out nice and clean, doesn't it? All right, good. Let's do the one with the kite, number 18. Sorry to bore you guys so much. Got heads on the table and stuff. I'm only trying to help you out. Remember, you got a test tomorrow. Just be really nice that you guys will at least give me a little bit of courtesy, just to keep your head off the desk. Just common courtesy is all it is. Yes, ma'am. You may. Take a pass. Alright, we've got a kite right here. Alright, and let's label it A, B, C, D. And R is the intersection. They tell you these two are equal and these two are equal. That makes it a kite right there, doesn't it? Having these two equal and these two equal, that automatically makes that a kite. Alright, let's see what they tell you. It says RC is 10. So that little bit is 10. Say what, let's do that in different colors so everything doesn't blend in. What haven't we used yet? I'll just use that. So that's 10. And BD is 48. BD, that whole thing right there is 48. And then it says find CD. Find CD. We'll just call it X. Is that alright? So what do you think? You said it already, Daniel. What is it? 24, right. Because remember, this short one right here, or the one that's between the two non-equal sides, that is being bisected, okay? So BD is being bisected. Now, AC is not being bisected, but BD is. So if that whole thing's 48, well, that would be 24, and that would be 24 right there. And you have to solve for X. Well, we have to do a little math. This is like the 4th time we've done this, isn't it? Okay. So look, remember, on a kite, the diagonals intersect each other at a right angle, don't they? And so look what I have. I got a right triangle. Everybody see that triangle right there? I'll just highlight it. This one, and this one. Okay, that's my triangle. I've got two sides, 10 and 24, and I got to find this one. So we use the what? What's it called? Pythagorean theorem. So we go 10 squared plus 24 squared equals x squared. 10 squared, I know that. That's 100. I don't know 24 squared, so let's put it in here. So 24 squared, 576. 576 equals x squared, right? Add them up. At 676 equals x squared. Let's see if that comes out to a nice whole number. So let's just put, let's do this. The square root of 676, and that equals, look at that, 26. So x equals 26. Do you understand why I did square root? Because I had to get x by itself. I took the square root of this, and I took the square root of that. So x is 26. Came out nice and pretty, didn't it? Remember the other day we talked about a 3, 4, 5 triangle? Remember that? This is kind of a special triangle too. Look what goes into both of these, or into all three of these sides. What number goes evenly into all three of these? 2 does, right? So 2 goes into this what? 5, into this what? 12, and into this 13. When we get to the chapter on chapter 8, when we get on the chapter of right triangles, we're actually going to be looking, they call them Pythagorean triples. It just means it's a right triangle when all three sides come out to a nice whole number, because that's not always going to be true. Most of the time, right triangles come out with at least one of the sides being some square root number, ugly number. Okay, but every once in a while, you get some special triangles that come out to be nice, pretty whole numbers. And one of them is a 5, 12, 13. So instead of doing all this work, you might have recognized it. You're like, oh, this is twice as big as 5. This is twice as big as 12, right? The 24 was. So this answer must be twice as big as 13. And that's kind of like your 3, 4, 5 triangle. Okay, so that's kind of like a sneak preview for what we're going to do in Chapter 8.
If you were to multiply them all by 3, would it still be the same thing?
Yep. Okay. Like, I could have a 5, 12, 13 that was like 15, what's that, 36, and 39. So if I had a triangle, a right triangle, that was 15 and like 36, without doing any of this stuff right here, I'm like, oh, 3 goes into this 5 times, 12 times, oh, 13 times 3 is 39, and it would have been just as easy as that. All right, so that's why the Pythagorean triples are helpful. You could have still gotten it doing Pythagorean theorem, but it saves you time. All right, it really does. We good with this? All right. Let's do that bonus problem. How about that? And then we'll be finished. We'll do it in this red. All right, it says, in parallelogram ABCD. So let's draw a parallelogram. Oops, wrong tool. Let's go to this one. So let's make this look like a parallelogram by doing this. Oops, I didn't want that. What did I go to? I meant to go to shear. That's what I wanted. There it is. Okay, there's parallelogram. It doesn't draw a picture for you. It just describes it for you. And it's A, B, C, D. So A, B, C, D. It says AB is 2x minus 7. So that's the top. It says BC, this one right here, is x plus 3y. And CD, this one down the bottom, is x plus y. Oh, this one is a little bit more difficult now that I saw the numbers that they put in here. That's why they made it a bonus. Remember, I read these off and I was like, why'd they make that a bonus? Yeah, this one is a little bit more, the algebra part anyway. I'll set it up for you. I'm not worried right now that you know how to do this algebra. And then it says solve for x and y. Yeah, this is going to be a little bit trickier. Let me see. Yeah. I don't even know if I want to show you how to do this. But if it's a parallelogram, what would you do to this one and this one? Set those equal to each other, right? And what would you do with this one and this one? Set them equal to each other as well, correct? The math does get a little bit more confusing, but it is something. Do you remember in Algebra 1 you did substitution and elimination? Do you remember you had a whole big stuff on that? Do you remember those words? You don't remember it at all? You remember substitution but not elimination? Yeah. See, that's the problem. If you didn't have this in Algebra 1, I'm not going to sit here and teach a whole Algebra 1 lesson on how to do this. But it's definitely something you're going to need to know when you take Algebra 2 next year. Okay? You want to see it? All right, I'll do it real quick. I won't have anything like this on a test, so don't flip out. Oh, I'll never be able to do that. Okay? Just watch and enjoy. Okay? So here we go. So I've got x plus y equals 2x minus 7, right? And what else do I have? I have 2x minus y minus 1 equals x plus 3y. All right, let's do this. What I'm going to do is I'm going to put all the x's and y's on the left-hand side, and I'm just going to put my regular number, right? Whenever I get a number, I'm going to put it on the right-hand side. So I'm going to subtract a 2x from both sides. And so what do I get? I get negative x plus y equals negative 7. All right? I'm going to put that in a box because we're going to use that a little bit later. It's not my answer. I'm just going to use it in a little bit. Let's do the same thing here. Put all the x's and y's on the left-hand side. Put the number on the right-hand side. So I'm going to subtract an x from both sides. And then I'm going to subtract a 3y from both sides. And I want the number on the right-hand side, so I'm going to add a 1 to both sides. Let's see what we get. 2x minus x is x. Negative y minus 3y is negative 4y. We cancel that out. This canceled, that canceled, and you have a 1 over here. Put that in a box. Now, here's elimination. I don't know. Maybe you remember it. Maybe you don't. I don't know. We'll see. I'm going to put these equations on top of each other. You don't remember doing this in Algebra 1 where you had when you had two equations with x and y on top of each other? Because you may forget. You may have forgotten the words elimination, but maybe you remember this. Does anybody recall that at all? Okay. So what we can do, and without any explanation, I'll just show you what we're going to do. What we can do is we can add everything together. So negative x plus x cancels out, doesn't it? Add these together, I get negative 3y. Add this together, I get negative 6. Divide by negative 3, and y is what? 2. Is that the answer I read off? Yeah? Now, if we want to solve for x, I could put that y either in here or in here. It doesn't make any difference. Let's put it in for this one. So it's x minus 4y equals 1. So that's x minus 8 equals 1. Add an 8 to both sides, x equals 9. And there you go, 9 and 2. I think that's the answers I read off, isn't it? I won't give you something where you have to do elimination. And that's why they made it the bonus. Now I know, okay, why they didn't make it a regular problem, because it is a little bit more involved with the math. Do you recall doing that at all in Algebra 1? You still don't? Wow. Yeah, it's definitely something you should have hit in Algebra 1. All right? You're going to definitely do it in Algebra 2. So, there you go. All right. Now I'm going to collect it tomorrow, the day of the test, okay? So you're going to turn that in. I think you had another thing, didn't you, the practice test? So 2 things. Now listen, a lot of you guys are missing points because you're not turning in the review stuff the day of the test. You forget about it and you put it off and you get zeros for it. So make sure you bring 2 things in tomorrow, the practice test and this worksheet right here. Okay, that is due tomorrow.